In this video, we're going to be graphing quadratic functions using X-intercepts. So let's do some refreshers really quick. So I'm going to explain what an X-intercept is. So an X-intercept is the point where the function crosses the x-axis. So here in our diagram, these points right here, these would be our X-intercepts. And as a refresher, intercept form is f of x equals a times the quantity x minus p times the quantity x minus q. So in intercept form, our x-intercepts are the p and the q values. Okay, our p and our q values. As a quick reminder though, because they're on the inside with the x, if we see a minus, our p and our q's are going to be positive. But if we see a plus, then our p's and our q's are going to be negative because they do the opposite of what they're seeing, because we're starting here with a minus sign already. And so in order for our p to be positive, that minus sign remains. But if that minus sign changes into a plus sign, the only way that happens is if we have a minus subtracting a negative. And so our p would have to be negative. So the x-intercepts in intercept form are the p and the q values. So how do you find or determine the axis of symmetry and the vertex from intercept form? So our equation is going to be a little bit different than what we would use for standard form. So for our axis of symmetry, so remember we use AOS sometimes for short, our equation is going to be the p plus the q divided by 2. And our vertex, our x value is always our axis of symmetry. So I'm going to write AOS here, right? And then the y value is when we take our axis of symmetry and we plug it in. So I'm going to write f of AOS. So when we plug that in and we get an answer, that becomes the solution for our, or the y value of our vertex. So let's go ahead and let's do an example. So here we're going to graph f of x equals -2 times the quantity x plus 5 times the quantity x minus 1. Then we're going to label the x-intercepts, the axis of symmetry, and the vertex. So what's great about graphing a quadratic function in intercept form is you really only need 3 points: your 2 x-intercepts and your vertex. So remember from above that our p and our q kind of right here, kind of waiting, ready to go. And so here we're going to have a p value of a -5, because remember we're taking the opposite of what we see, and a q value of a +1. Now what that's going to convert to is our x-intercept points. And so that's going to be the point -5, 0 and 1, 0. So we have 2 of our 3 points. So all we need to find now is our vertex. And so to do that, we're going to start by finding our axis of symmetry. And remember that equation is the p plus the q divided by 2. So let's go ahead and let's plug that in, right? So we have a p value of -5, and we're going to add that to our q value of 1, and then divide that by 2. Which is going to give us a value of -2 for our axis of symmetry. And so in order to find the rest of our vertex, right, because we know that it's going to be -2, something, we need to take this -2 and we need to plug it in to our x values. So let's go ahead and do that. And so here we have -2 times the quantity -2 plus 5 times the quantity -2 minus 1. And that's going to give us a value of 18. Okay, so we have everything we need to graph. We have our x-intercepts, we have our axis of symmetry, and we have our vertex. Now if we look at our vertex goes up all the way to 18. And if we look at our coordinate plane here, there are 18 spots on this top half right here. So we have to decide what number we need to count by. Could we count by twos? 2, 4, 6, 8, 10, 12, 14. Nope, not quite enough. But what if we were to count by threes? So if we were to count by threes, we would have 3, 6, 9, 12, 15, 18, 21. So we could count by threes and that would be just fine. So now we have to decide on our x-axis, are we going to count by threes as well? Or could we still count by ones and would that be okay? And I see no reason why we wouldn't count by ones. We have the numbers -5 and 1, and both of those will fit onto our coordinate plane. So we're going to go ahead and start graphing. So we're going to graph our vertex first at -2, 18. So there we have our vertex. And now we can graph our two x-intercepts, -5, 0, and 1, 0. And here we have our wonderful axis of symmetry. And if we check, we can see that we are 3 places away from our axis of symmetry here and 3 away from there. And so really all we have left to do now is to draw our parabola. And so here we have our graph. And now we just need to label. And so right here, we see that we have our vertex. And again, we want to label that on our graph and then make sure that we can find that in our answer as well. Here we have our axis of symmetry. And again, we want to make sure that we've got that there, as well as being able to find that in our answer, -2. And then our x-intercepts. And so we've got our two x-intercepts that's on our graph, and then as well we can find right there. And so that is how you graph when you are giving it your equation in intercept form.